And it's now an honor to welcome Capitán de Navio Carlos Zuñiga. He is the Director of Servicio Hidrográfico y Oceanográfico de la Armada de Chile, SHOA. Captain Carlos Zuñiga is a hydrographic engineer, category A hydrographer, and holds a master in physical oceanography. He has served in the Chilean Navy for nearly 30 years, spending most of the time of the career in the Hydrographic and Oceanographic Service, JOA, where he currently serves as director. Over the past 13 years, Captain Zuñiga has dedicated his expertise to enhancing and developing the Chilean National Tsunami Warning System, working in close collaboration with SENAPRED and both local and international academia. He served as the Associate Director of the International Tsunami Information Center from 2013 to 2023, and is currently a Vice Chair in the Intergovernmental Oceanographic Commission, IOC, of UNESCO. Today, he will present Chile's National Tsunami Warning System. Please join me and welcome Captain Carlos Zuñiga.
Hi, good morning. I feel in disadvantage because I'm only one person. The reason we're three people with some effects, light effects. Well, but today I would like to introduce the National Tsunami Warning System. When I was contacted by the organizing team about this opportunity, I felt very honored because it's important to present our work to such a big group, because the job that you are doing is incredible, because you are talking about science and numbers, a lot of screenshots about a lot of numbers, but the importance of your work is that it's something that useful for the community. So you are doing a lot of science, but the effects of your work, we can see it every day. So I am very honored to present my work because I think we are very well linked. And I'm here to present you about the National Tsunami Warning System. Let me check the time because I'm very good speaking, sorry. But also would like to take advantage of to present you what SHOA is doing actually, because SHOA in Chile is synonymous of National Tsunami Warning Center. However, we have a history of 152 years, and we have a mission that is given by a supreme decree. And our main task is to provide safety for maritime, river, and lake navigation. It means that we have to provide information to the users, marine users, in order to have a safe navigation in our jurisdictional waters. And also we are the official service of the Chilean state for several tasks: hydrography, nautical cartography, oceanography, tidal waves. Tidal waves is an old way to mention tsunamis. So tsunamis is just in between of our tasks. Nautical geography, navigation, nautical astronomy, and time signals. Yes, we are in charge also of the official time of the country. And most of those areas are well related to GNSS. So as you can see, and also you probably are working very closely with cartography, and we are doing that kind of jobs here in Chile. And as well, we must to contribute to the marine science. In SHOA, we have the headquarters of the Hydrographic Service, but also we have the one organization that is called CONA, the National Oceanographic Committee. So I'm the director of SHOA, and also I'm the president of CONA, and that is an organization that brings together 33 different institutions of the country in order to use wisely our very small budget for marine science. So the importance of SHOA, first, our letter H, it means hydrography from our name. And hydrography is very important for Chile because we request for nautical cartography, especially for a country like Chile. We are not an island, but we are similar to an island because our economy relies 95% in marine traffic. So we request accurate nautical cartography. And as well, if we consider all the telecommunication cables that are using also the information provided by SHOA, is something important. That is the reason why we have 363 paper charts and a similar number with electronic charts. I'm not sure if you are related, but the electronic chart is changing. For 2029, we must to changed our actual standards that is called S57 to a new one that is called S100. And S100 is going to be linked closely to GNSS information as well. And also the letter O from our name is oceanography. And well, I will talk to you about the National Tsunami Warning Center that is part of that O letter. But we have a network that is continuously monitoring different variables that are useful for a climate change index, like sea level, like sea temperatures, and also waves. Because because the climate change, we are facing several storm surges during the whole year. And as well, we provide operational forecasting information for navigation, not only for marine users, also for the Navy. And we provide technical support for marine scientific, especially with CONA. SHOA is not a big institution. We are only 270 people. And as you can see here, we're almost 50 and 50 with Navy people and civilians. So it's a place where we combine very perfectly the knowledge from Navy and also knowledge from academia and civilian people. So I really enjoy being there for almost my whole career. So it's a great place to work, and probably many of you already visit our service. So now, that was a very quick introduction of 5 minutes. So moving to the National Tsunami Warning Center, this is a picture of our operational room. So it's located in Valparaiso, in Playa Ancha Hill. It's a very nice place in the top, of course, out of the inundation zone, because we must be in the safe zone. And it's an old building that started with only one house, but then we bought all the block. And there is the place where almost the 270 people work. We have one alternative ops room very close to the main one, and another in Viña del Mar. So we need redundancy. That is something very important that I will explain you later. And redundancy is important in a country like Chile. So you are here, probably you came here during the weekend, and I'm pretty sure that you hear in the news, or probably you felt an earthquake, a 6.0 last Sunday. But for Chileans, 6.0 is like nothing. So it's, okay, 6.0. We were drinking some tea, so nothing happened. And we had some aftershocks after that earthquake. So probably it's the best place for studying GNSS information, maybe. I was listening to the previous presentation. And actually, yesterday, in 1 hour, we had 13 earthquakes in Navidad, a place that is 100 kilometers to the south from here. So 13 earthquakes. I was prepared. I was ready. I was checking the battery of my radio. Also, I called to the people on duty. They are always alert, but just to be sure that everything was working perfectly. Because in a country like Chile, we can expect to have a big earthquake like the one we had in 1960. So the strongest ever recorded on instrumental area earthquake, a 9.5 in Valdivia, that caused a trans-Pacific tsunami, causing casualties in Japan, Hawaii, the Philippines, in many other areas of the Pacific, because our countries weren't connected. So we didn't have a system that was built after that event, a system that is called the Pacific Tsunami Warning and Mitigation System. And that system started nearly in 1960. And that kind of organization, now we have it in the other ocean basins. So right after that event, also Chile, we used to be a reactive country. I'm saying we used to be because now we are trying to act in advance. We established the National Tsunami Warning Center, and we call it SNAM, Sistema Nacional de Alarma de Maremotos. So our National Tsunami Warning System was established right after that event. But I would like to emphasize in something. This is the 9.5 was the strongest recorded on the instrumental era. So in the history of the Earth, the 4.5 billions of years, the instrumental area is like nothing, nothing. Less than the time of the blink of an eye in one day if the whole history of the Earth was one day. So we must be prepared for everything, because in the past, I'm talking about 1950s, probably nobody imagined to have a 9.5. And actually, we had on 2022 a tsunami that was triggered by a volcano, the Tonga Apai. I was practicing that name. And that was a very rare event, but rare for us, for our history. The instrumental area is about 200 years. We can find history, written history of 5,000 years, at most. So we must take in consideration that we are just a tiny part of the history of the Earth, and we must be prepared for everything. And then the National Tsunami Warning Center systems in the world are focused mainly in earthquakes, because the 81% of the tsunamis are triggered by earthquakes. It doesn't mean that we cannot have another source, like landslides, volcanic eruptions. All you know about meteorites and what's the name? Chukchulub in the Yucatan Peninsula that caused the extinction of the dinosaurs. So we should be taking in consideration all the kind of sources, but our protocols, and not only in Chile, I would think that most of the countries and the systems, ocean basin systems, are based in protocols for earthquakes, because are the most common. And that doesn't mean that we are not able to respond in case of another source. For instance, in 2022, once again, for the Tonga event, we also provide our assessment to the National Risk Reduction Office. So we did it. We did it because our muscle, so we go to the gym to train our muscles, but our muscles can be used for different things. And we use our muscles mostly for earthquakes, but also we can use it for volcanic eruptions. And as well, here in Chile, we had in 2006, I think, a huge landslide in the fjord of Aysén, 11 casualties because of the tsunami. So we must be prepared for everything. And I mentioned during the explanation of the letter O about storm surges, because we usually receive in coastal countries like Chile some alerts about storm surges. So the authorities say, okay, we are expecting to have a storm surges in the coast with waves amplitude of 2 meters, 3 meters, and some areas are used as buffer in order to avoid any kind of casualties or issues. So in our coast, we have wave breakers, we have walls that dissipate the energy, and I would like to take your attention in these two videos. The first one is showing a wind wave of any given amplitude, I will say 1 meter amplitude, and as you can see, the wave breakers are very useful, they're able to dissipate the energy without any problem, so we have only some splash over the coastal roads. And in the other video is the same amplitude, so we are only changing the wavelength. Same amplitude, different wavelength. So there was a 1 meter amplitude tsunami wind wave, and the other 1 meter amplitude of a tsunami. So the difference is huge. So we are dealing with that because we need to build awareness in the people, in the communities, and that is why I enjoy that kind of activities, because we must understand the difference between a wind wave and a tsunami wave. So it's a huge difference. And also, one thing is the amplitude, other thing is the wavelength, but as well the velocity of the wave. So this is a tsunami wave of 50 centimeters, only 50 centimeters. Probably we are not going to die with this wave, but we can be hit by a debris, But also, if you consider this effect in a child, probably the consequences could be fatal. So it's a risk. So that is why we are very preventive in terms of tsunamis, and we don't wait for the measurement of the amplitude for trigger an alert. We must to do it in advance in order to avoid that kind of things. Because tsunamis are also very fast, 50 kilometers per hour in the coastal areas. So if we see a tsunami, probably we're not going to be able to run, to escape about that. And in the world, we have the ranking of the earthquakes, and for sure, our 9.5, we were very bad in playing football or soccer, but we are good in earthquakes. And also, we are a country that we export tsunamis because every time that we have a big earthquake here, the consequences are also in Japan, in Hawaii, in Tonga, and it's the same the way back. We have experiences from Alaska. The tsunami from Kamchatka came to here. Sendai came to here. Tonga came here. Kermadec came here. So we are like a magnet for tsunamis. And the reason is because the bathymetry and also the effect of the rotation of the earth. We have all the waves coming to Chile. So the history of international earthquakes, but also I would like to mention you about the national earthquakes. Here, some of you are Chileans, and my question will be, what was the earthquake that killed the biggest number of people in Chile? So the quick answer will be the 9.5, because it was the strongest. But no, it was from 1939, it's over there, an 8.3 in Chillán that killed, non-official numbers, 30,000 people. 30,000 people, 1 century ago almost. And no tsunamis. So we are dealing with that. In our National Tsunami Warning Center, we are dealing with intraplate earthquakes, interplate earthquakes. So that is also something very complicated because we need to act very fast, very quickly, and we are dealing with that. So in the recent past, we had the 8.8 in 2010, and that was a tipping point for our country in the national risk management. That is why ONEMI was changed to SENAPRED, local institutions. That is also how SHOA improved and enhanced the Tsunami Warning Center, and as well how the National Seismological Center changed from a service of during office hours to 24/7. So it was a very important change back in 2010, and now I will present you all the effects of that changes. But also, with that information and also using GNSS data, we're able to identify our seismic gaps. And seismic gaps are very important because, okay, we were talking recently about the last Sunday event, and the last Sunday event is in a seismic gap. I'm not sure if you can see it there, but in the central part of Chile, where the Quintero city is located, we had the last huge event was back in 1730, so almost 300 years ago. It was about 9-ish magnitude event with a tsunami with very important impacts in Chile. We see some evidence in the sediments, but also some information was found in Japan because we export in the past also tsunamis. So the information was also obtained in Japan from 1730. And it's something that we can expect here. We can only because from numbers we can expect to have that kind of headlines, that a 65% of probabilities to have an earthquake of magnitude 8. And that was given by the director of the National Seismological Center a couple of months ago. Why? Because around every 12 years, we have an earthquake of magnitude 8 or above in Chile. So be aware, because if you are visiting Chile for a longer time, the last big earthquake that we experienced here was in 2015. So we are close to 2027, so be aware of that. But also, I would like to tell you that here we have a very strong system that will provide you some information in your cell phones and also infrastructures, because here in Chile, all the buildings are built to save lives, and that is something that I feel very, very proud of that. And well, data that we can obtain from GNSS, and that was the massive event back in 2010 with an earthquake that started in one point, but finally the most energetic area was in a different place. It was an earthquake of about 400 kilometers of rupture, and the tsunami was spread out around the Pacific, and also with important casualties here in the archipelago of Juan Fernandez and areas within the country and also outside. But after that, I think that our system has been improved a lot, and we have some recognitions, not only local, so also internationally, because, okay, SHOA, the service that I'm honored to be the director, is the focal point for IOC UNESCO, and we are responsibly in the management and also especially in the assessment of the tsunami hazard in Chile. And as well, we have several recognitions because the positions that we have held in the past, like myself, I was the associate director of ITIC for several years, and also we had been the head or the chair of different working groups, not only in the region, but also in the Pacific and as well globally. And the United Nations gave us a recognition to the Chile, especially the UNDRR, because they say that we are one of the 5 more advanced national tsunami warning systems, and I will present you a video about that. And that is a huge honor, but also a very heavy responsibility, because if you are in the top, so if you fell down, the hit is going to be harder. So we are dealing with that responsibility, and we take in consideration everything. So that is why I was talking about redundancy, protocols, and go on. Scientific validation, we have our system, our tailor-made decision support system that has been referenced by different index scientific publications. And also recently we were endorsed as one of the ocean decade actions for the IOC UNESCO. And about the 5 most developed tsunami warning systems. So we have this video that was created by UNDRR. I like this video, not only because for the information, but also for the pictures. USA, I think that is Hawaii, nice island, huge building. Japan, heritage, culture. Australia, opera house. Chile. And that part of Chile, I think that is Puerto Saavedra, and India as well. Puerto Saavedra, that was one of the areas most affected by the earthquake and tsunami of 1960. So once again, it's a big honor, but also we must be prepared for the response that our communities demand. So that is why we have our system, once again, it's called SNAM, Sistema Nacional de Alarma de Maremotos. We have a Supreme Decree from 1966, and we have 5 pillars of our system. The first one, advanced technology system with national scientific contribution. And that is very important, because in the past, we used to request for collaboration from overseas, from different countries. A strong support from NOAA, a strong support from DLR, a strong support from the European Union, the PECO programs, also from Japan, but with the issues that we usually have, like language barrier, like time zones, like budget, because if we request and if we demand for a training, we must to travel or they have to come here. So we start working with our local academia. And when I'm saying local, it's real local, because we are in Valparaiso, and 2 And in the same area, we have the Universidad Santa Maria, and they help us to develop our decision support system. Also, high level of professionalism and training. Training for us is the key. We have a training every single day. Christmas, we don't care. Independence Day, we don't care. Birthday, so it doesn't matter. We have to train every single day. Actually, last Monday, we had a drill not only for Chile, it was a drill from Colombia to Chile, Colombia, Ecuador, Peru, and Chile. So we have that kind of drills 3 times a year. We have a drill every 3 months with the National Seismological Center and also the National Disaster Management Office. And we have our daily drill. For us, training is the key. And we train for everything, for a massive rupture of our offices, for failure of communications, and so on. So we have people with a big imagination, so they create very sophisticated scenarios in order to challenge the team. Redundancy in monitoring, command control, and communication systems, so also it's quite important. We don't only rely on one system, nor in 2 or 3, or no, only 3. I have only three here. But we are always well connected because the communication is very important. So we can have a nice and very fine assessment, but if that assessment is not conveyed to the authorities, so the system will fail. So we're taking in consideration that. High cost of maintenance and renovation, budget is always an issue, and we operate under national and international protocols. And that is something that I would like to emphasize because we felt very honored because some of our local protocols were included as international protocols. So we are not only exporting tsunamis, we also are exporting protocols because we train every day. And we had the 2015, the 2016, 2022 Tonga eruption. Last year, we have 2 big events in the Drake Passage in the south of the country. So we have our trainings, we have our drills, but also we had some experiences with real events. And that is not something so usual in other places of the world. So we are a system. So as a system, we are different components. One is the National Seismological Center, then SENAPRED, and also SHOA, that is the organization in charge of the system. So that is an example of a local event. So like the event that we had on Sunday. The first information probably is going to be the shake by itself. But if we don't feel that shake, SENAPRED will provide us the information of intensity because they have a very dense network of people that is informing intensity to SENAPRED. Yesterday, this equipment was giving reports every time because in 1 hour, 13 earthquakes in 1 hour. So I received a lot of intensity information, but the largest was 4, so nothing too big. And that is the first alert. So once we receive that information, so we say, okay, something is happening. But that is something very important because time is clicking and we need to act very fast. And for us, if we have an earthquake and if we wait for the official information, probably it's going to be too late. So in case we experience an intensity 7 in coastal zone, the local authorities can activate the evacuation protocols without any official information from SHOA. So only because the intensity was too high and they were in the coastal area. So that is something very important. Because once the earthquake starts, the National Seismological Center have 5 minutes in order to provide the official information, depth, epicenter, and magnitude. And after that, we have 5 minutes. So in the worst case scenario, after 10 minutes, we will provide the official assessment. In the reality, it takes about 6 minutes because they take 2-3 minutes, and for us it's the same. But those are our protocols. So the system, the whole system is like that. CSN at the top because we rely on the information from a seismological center, but also we identify some other official sources. So NOAA, I see some NOAA folks over here. I saw at least some NOAA stickers in in some agendas. So it's twice. Why? Because we have the Pacific Tsunami Warning Center in Honolulu, Hawaii, and also we have the National Tsunami Warning Center in Alaska, Palmer, Alaska. And as well, GFC from Germany and USGS also from the United States. So they provide the seismic information. SHOA, we operate the SNAM, and we need to provide the assessment of tsunami, and then we send information to the authorities. And that is something very important in our system, because we, as SHOA, we are not in charge to disseminate the information to the public. It's Senapred, and also in the maritime and the Navy domain, the two other institutions. And as well, in parallel, you can see their monitoring network, because we have our own monitoring network, and also we use information from other countries, mostly in the region, Colombia, Peru, and Ecuador. We, the Southeast Pacific, work very closely together in order to have a good assessment of tsunamis. And in terms of timing, so SNAM, we have different stages. The first one, of course, is the activation, then the information reception, and after the reception of the information, we have the 5 minutes stopwatch that start clicking, and after the assessment, we provide the information to the authorities, and then we move to the monitoring, which is very important, and then the cancellation, that is also a very important stage of our procedures. But this is a cycle. So we receive the information, and we have 5 minutes. But in the ideal world would be like, an earthquake, ping, we receive one email, a W face from CSN, and that's it. But in the reality, we receive, maybe for a 8 magnitude event, in the first 5 minutes, we will receive 20 different solutions each from all the 5 different sources, official sources, and also CSN that is giving the W phase answer every couple of minutes. So the team is prepared for provide assessment in about 1 or 2 minutes, but we need to take the worst condition in those 5 minutes that is given by protocol. And then if we have a worse condition after the 5 minutes, well, we release our first assessment, and we can release another assessment then. And the monitoring and also the cancellation, and that is important to have a great monitoring network that I will show you later. But our assessment is given by a system called CPAT, Sistema Integrado de Predicción de Alarma de Tsunamis. It's like integrated system for tsunami forecasting. And in the beginning, that was with a great support from JICA, also a fantastic help from DLR, but then we took the post. So, okay, thank you so much, but now we have the knowledge, we have the academia that was very involved in order to obtain the solutions that we requested, and we prepare a tailor-made system, a decision support system that allow us to divide the country in 21 different blocks. And this system is using pre-model events. So far, we have 15,000 pre-model events, not only in the national domain, also in the regional, from the north of Mexico to the Drake Passage and also Antarctica. And with this tool, we are able to provide the tsunami assessment for our country. So how it works? So we have the magnitude and the location of the earthquake, and we establish a window, and in that window we will find several candidates. For example, 10 candidates, and each candidate have 1,000 of forecast points. Each candidate 1,000 of forecast points, and the system combine the worst solution of every single forecast point, and that is the solution that we provide as our assessment. But that is something that we need to take in consideration, that we are using an homogeneous source as part of our system. So that is how GNSS can come to here and provide probably a finite solution in order to have a system more robust. And that is something that we are working with CSN and other organizations. So before CPAT, so I have an example here of the 2015 event. Before CPAT, we had that event in September, so we send our assessment to authorities and we say, okay, we will have a tsunami threat level of alarm for the whole country. The earthquake was in the central part of Chile. You can see there the red dot. And Senapred on the National Disaster Management Office received some questions. So from the south, from the Magellan region, they say, oh, are you sure that we will receive a tsunami of 3-meter amplitude here in Punta Arenas? And they answer, of course, because SHOA is telling us that solution. Okay, they evacuate. What happened? Nothing. But because we had the same threat level for the whole country, but if we consider the area of the epicenter, we experienced a tsunami of 5 meters high, 5 meters. So a huge tsunami. But after that event, that was in 2016, we released CPAT, and that would be the solution if CPAT would be able for that time. So the country divided in the 21 blocks, and some areas with important evacuations and some others without any evacuation. So that is the importance to have that kind of systems. And now we are working the implementation of phase W in order to have a more accurate and quicker response from the National Seismological Center. And of course, the characterization of the seismic source is something important, and there are some work with GNSS information, because as I mentioned before, we use a homogeneous source in our system, and probably we can improve it using this kind of information, and I think that will be a great opportunity of collaboration between both areas. So after assessment, now then we have the dissemination of the information, and we have several ways to convey the assessment to the authorities. Of course, Starlink came to change our connection with satellites. So now almost everyone is able to have a satellite dish for internet, but in the past it wasn't like that. So now also we have some satellite telephones, but satellite telephones are different than the smartphones. So you need to understand how to call. And you can say, oh, that is something, it's a silly comment, but it's not. But because you need to train that thing as well. You have to train everything. You have to train from using very sophisticated system like CPAT to train how to call in an emergency using satellite phones. Because when you are in an event, your heart is going to be beating very quickly. You will get nervous, and you need to know how to do it. So we have several ways to communications. Also, we have 3 different rooms, operational rooms, and as well in our protocols, if the National Disaster Management Office don't receive any answers from SHOA, they also know what to do. So we have different stages and steps in order to always provide a solution to our communities. And the solutions, for the solution, we have different threat levels. The green one is no action. Then we have the yellow. That is, I would think this is the most challenging tsunami threat level, because it's like in the gray area. It's a tsunami, but it's not too harmful, and probably you wouldn't see some huge effects, and the media is going to be pressing you because, oh, where's the big wave that we watch in the movie of San Andreas Fault? So it's something that we need to deal with, but then we have some other threat level, warning and alarm, where the population must to evacuate to the 30 meters above the sea level areas. And also for monitoring, we have once again, we are very proud about our network. We have 49 tide gauges, sea level stations, where we are able to obtain information in real time of sea level, which is useful for tsunamis, but it's also useful for tides forecast. It's also useful for climate change. And as well, well, that kind of network provides you all the information on shore, so in the coast, but also we have offshore data that is provided by the DART systems that are not useful for local events, but also contributes, or the first response, but contributes for monitoring, for cancellation, and also for the forecasting in the whole Pacific. Our tide gauges are tailor-made because that is a way that we build, and also it's in the manual of the IOC. It's a global manual that we provide as an example, and now it's used worldwide because it has a H frame, so the water flows can go through the tide gauges without impact, huge impact. And we have two different power systems, two different communication systems, two different data from radar and from pressure. So redundancy also is a key here. And we have our network with our 49 sea level stations, and also we are part of a global system because we request information from other areas. So over there in the top, you can see the IOC sea level data facility, and that platform, every single green dot, it means that we have a tidal information from different places. And as you can see there, Chile is full covered. And also, I was talking with Jose Antonio, and probably it's a good opportunity for a good combination of using UNSS with the data of sea level, because we don't have that information together, and it's important because the change of the seismic time. And as well, for that system, we are part of an international network, and we have 5 in our country. And you can see there, we are one of the very short list of countries that maintain a robust network of information. And the last part of our system is the cancellation, and downgrade the tsunami threat level is not something easy. So we must be sure that we are downgrading the threat with information, with data, with forecast, with witness people that is providing some other kind of information. But it's important to say that SHOA is not in charge to lower the level. It's SENAPRED, the National Disaster Management Office, because they are dealing with more things. We are seeing that, okay, the tsunami threat is already over, because we are not seeing the waves, but they have to deal with sanitary issues, with power, electric power, and so on. So they are in charge to downgrade the information. So that is how our system works with all the stages, but also we are part of the full cycle of risk reduction. And in the past, I would say in the late 90s, SHOA started doing something that we call SITSU, Cartas de Inundación de Tsunami. There are inundation maps. We started with a very strong collaboration with JICA, GMA mostly, the Japanese Meteorological Agency. And we developed our chart. And now, when one law, we call it the SENAPRED law, was released, that kind of information now is binding for territorial planning. So that information is useful for infrastructure, for private investment, and so on. So I think that is very important. And actually, we have 77, every important city in front of the coast have their own inundation maps, also the ports. And now we are doing the different other versions. Now we will release another version for Viña del Mar, Valparaíso, and as well for Easter Island. So it's going to be in during the second semester. So we are contributing in the response for a tsunami, but also in the full cycle of risk reduction. And just finishing, I'm doing great on time. 2 minutes left. I think that we cannot predict any tsunami, but we must be ready for our response, because we are one of the top 5 national tsunami warning centers. So our communities, the Chileans, rely on our system, and we must be ready for any kind of response. So thank you very much, and we have 2 minutes for questions and answers. Thank you.